Hello, in this lesson we'll be going over exponents and exponential growth, and this is a new topic. We're going to set up a little scenario here. We have Bob and Bill. They just got hired at two different jobs. They're only going to work for 30 days in this scenario, and Bob and Bill are going to get paid in two different ways. So Bob, he's going to get paid $500,000 up front before he even starts, and then another $50,000 per day every day for 30 days. And then he gets them out on the 30th day. Bill, he's going to get paid differently. He's going to start at a cent on day one, and then it's going to double. It's going to come 2 cents on the second day, double to 4 cents on the third day, double to 8 cents on the fourth day, and it keeps going until day 30. Whatever amount is on day 30 is how much they get paid. Who is going to get paid more? Okay, so let's just set up some information. We know that Bob, he starts with $500,000. We know that we're going to add $50,000 a day. And so instead of filling that out all the way, we can make an equation, right? 500,000 plus 50,000x. We plug in 30 for 30 days, and then we get Bob having $2 million at the end of this. Okay, so now let's see Bill, right? He only starts at a cent, not very much. So he starts at a cent. And so what happens when you keep doubling? Okay, 2 cents, 4 cents, 8 cents, and feel free to please pause this and to write these down if you need to, because I'm going pretty fast. By day 10, only at $5 still, right? So we keep going, we keep doubling. We see on day 14, this is after 2 weeks. 2 weeks, still only 80 bucks, right? There's no way it's going to get close to this. How? It doubles, and so by day 20, right, 163, 327, we're up to $5,000. Still nowhere even close to 2 million, right? So day 21, 22, 23, by day 25, we're at 167,000. And when we keep doubling this, by the time we get to day 30, Bill is actually going to have over $5 million. So if we had the choice, we'd go with what Bill got, right? And so our conclusion is that, Bill's going to make more money, because 5 million is greater than 2 million, and the conclusion is that this exponential growth rate can grow much faster than linear. And so this is an example of exponential growth. Everything we've been doing so far is linear growth, just adding the same thing each time. So when someone says something like it's growing exponentially, that means that once it starts growing, it grows very fast. And so the definition of an exponent, we're going over exponents and exponential growth. Okay, so an exponent represents repeated multiplication. Very important. Okay, and as a review, multiplication from before was repeated addition. So that means we need to know what the symbol of an exponent is. So the symbol of an exponent is when there is a small number up top. Right, so this is the base number, and then we have the small number up here, so that's an exponent. And so what that means, right, we need to know what the symbol means. It means that we're going to take that 3 and repeatedly multiply it by itself that many times, 4 times. Right, so this would be like the expansion, multiplication version, and then you can put that on the calculator. You can either put it as an exponent in the calculator, or all this as a calculator, 81. Right, so we apply that. We see the phrase 10 to the power of 3, 10 to the third power. We remember this means repeated multiplication, so that means we take that 10 and we multiply it by itself 3 times. Right, so this is how we show the work, because we can put these both in the calculator, and this would equal 1,000. And so note how this negative 10 to the third, if you want to simplify this, when you put this directly in the calculator, like this, you have to make sure that you put parentheses, and we'll kind of explain why later. It's less important in this example, but we remember the exponent is repeated multiplication. We take that negative 10, multiply it by itself 1, 2, 3 times, and then that gives us negative 1,000. And even when we have a multiplication and an exponent like this one, we have 3 multiply 4 to the third power. Right, we have a multiplication and an exponent. We have to remember order of operations. We need to do the exponent first. So that's the first expansion we want to do. So we circle the 4 to the third, because that's what we want to complete first before we do anything with the 3. So since we're not doing anything with that 3, we'll rewrite that 3. It's still multiplying. And then we can write only that 4 3 times. So only the 4 gets expanded 3 times, so the 3 is above the 4 only. All that in the calculator, and we get 192. And remember, you can enter this in the calculator to get 192, and you can also get this in the calculator to get 192. Right, so it's just important to know for this one that only the 4 is the one that repeats 3 times. And in our last examples, we have sequences, and our sequence or rate of change is going to be a multiplier. And so to find our rate of change, we can set up an equation. So we know since we are multiplying a number each time, right, it's going to be the equation we're going to make to find the multiplier is 10 multiply our multiplier, we'll put a question mark, and that equals the next number, 20. Right, so we'll set up an equation, we'll solve it, and we see here that our multiplier, our question mark, is going to be 2. I know this says, remember, you can find the rate of change, it's 2, but yeah, you guys know what I mean. So our multiplier is 2, so that's what we multiply. 80 times 2 is 160, and we know when we go the reverse direction, instead of doing 10 times 2, we do 10 divide 2 to go backwards to get 5. Lastly, we have one last example. This one we won't do. We know that we are multiplying, so we have a multiplier, so that means we know that 3 multiply something that represents the rate of change equals -6. We divide both sides by 3 to get our multiplier by itself, and we see here that the multiplier is -2 this time. So we keep multiplying by -2. Negative times negative is positive 48. Go the reverse direction, 3 divide -2 gives us -1.5. Thank you for listening.